Okay, now the recording is on. Good evening. Okay, now Umar, right? So earlier you were speaking, Umar, right? So,
Yeah.
so what you are saying is, we'll take a small scenario here, and then if we have a requirement, how do we translate that requirement into code? You know, we have a specific requirement. So let's talk about that requirement, right? So so tell me the requirement, or I can write it here itself. So I'll say, I'll create a new package. Training Java core. I don't know, lack of better words. Basic design, right? Okay. Now I'll create a new requirements. So what we are trying to do here is we will write down the requirements, and then we will translate those requirements into code. How do we do that? So what Uma was asking a few minutes back is that she has some ideas in her mind, but she doesn't know how do we translate them, right, into exactly code. So that's what we'll work on. Okay. So tell me, Uma, we need to design a car, right?
Yeah.
Okay. Design a car with a seat belt. Huh? That's what you're saying, right? Design a car with a seat belt, right?
Yeah.
Okay.
Or I have to write a method involving the
First,
feedback.
let's think of objects, right? So
Okay.
we have car and we have the seat belt, right?
Yeah.
Design a car with a seat belt. Now, if seat belt, when you start the car, if car is in start mode, okay, meaning if it is running, if it is start mode, and seat belt is actually in the real car, does it ask you to put the seat belt even when you are not driving? Meaning even if you completely stop and put your gear in parking, does it still ask you to put the seat belt? No, right?
That's a good point. No.
I don't think so, right? Okay, let's complicate the things, you know, just out of the.
Yeah.
So if car is moving, right? Car is moving, the seat belt is required. The seat belt is required, right? If seat belt is not, what do we call? If it's not buckled up,
Clicked. Yeah.
if seat belt is not clicked or buckled up, or okay, indicator should go on. Okay, indicator should go on, right?
Yeah.
So yeah, indicator should go on. If car is maybe started, or if car is started and not moving, seat belt is not required, right? Seat belt is not required, correct?
Yeah.
When car is stopped, the indicator should be off, right?
Yeah.
And The seat belt, yeah, seat belt will still be there, but indicator should be off, right? Okay. That is good enough, right?
Yeah, yeah.
Can we translate this into code? So let's do it, everybody. So what is the first class? You guys, you tell me, what is the first class that we are designing?
Car.
Right. Boy. Venkat Krishna, I believe that's you or somebody else. Can you please? I think you are using the speaker, so you have to mute yourself. Sorry. So, Jyoti, we haven't come to any topic yet. Okay, I wanted to discuss about inheritance, but Uma was asking. So she has certain ideas, but she's not able to translate that into code. So how do we do it? I'm doing it one more time. Let's put it that way. Okay, we'll spend about 15-20 minutes quickly. I mean, we did it, so I'm assuming. So, well, let's move on. So, okay, yep, no problem. But I need I need everybody's help in this one. So, what is the first class that we do it? Car, right? Uma, you tell me.
Yeah.
So, car, right? So now tell me the attributes of car, state. Especially keeping this in mind, these requirements in mind. Okay? So you can definitely have something like a make, model, win. Maybe you can, make, model, win. These are standard stuff, right?
Yeah, yeah.
Right? You can definitely say, I mean, these will exist, right? Now, make, model, win, forget about it. Now, if car is moving or not, so how do we find out if car is moving or not?
How do we find?
Yeah, how do we find out?
Start, or if it is started?
No, at any point, see, my seatbelt logic required on whether you are moving or not. How do I find out if car is moving or not? Tell me.
The speed is greater than 0 or something like that.
Absolutely. Who said that? Sailaja? Or someone said that?
It's Lena.
Oh, Lena. So, if the car's current speed is greater than 0, then car is moving. You agree, Uma?
Yeah.
Right? So, what do we need here? What do we need here for car?
Speed.
Current speed. Current speed,
Current
right?
speed, yeah.
So, what type is that? What data type is that?
Int.
Good. Current speed, right? Good. Now, tell me who changes this state? Who changes this state? When
Who is driving the car?
So when does this current speed change?
Whenever we start the car. The current
When you
speed
start
change.
the car, does the current speed change?
No, when we start driving the car, basically. Like,
So accelerating, right? So once you,
Accelerate.
when you accelerate, this will change. And when you apply the brakes, does it change too?
yeah,
Right? Good.
yeah.
Very good. So if the car is moving, the seat belt is required. So what do you think here? Seat belt. Now we need a seat belt, right? Right? So what do you think?
And an indicator.
Now, so you want to design the seat belt on or not? You want to design that as what? Tell me, what type is that?
It should be a string, right? Car has a seat belt.
Car has a seat belt. Good. So what
Car
is
has
string?
an indicator.
So what is the
String.
string? Well, what are the values of? Let's say if I say
Boolean, maybe.
Exactly.
Mm.
So private boolean seat belt on or off, right?
Okay.
Buckled, all right? Private boolean buckled, right? Whether it is buckled or not buckled, right? And you can also argue that seat belt itself can be an object. We are talking about a simple scenario here, but you can also complicate the things and argue that seat belt itself is an object, right? Seat belt is a big system. One of the properties of the seat belt is it will tell you whether it is buckled or not. And also in the seat belt again will have probably make and model, all of that, and then you can pull the seat belt and you can do it, right?
Yeah.
But we are just to make things easy, we are taking it as a boolean buckled. Everybody agrees with my argument? Just to keep things simple. Now, the seat belt is required, meaning you need to be buckled. If seat belt is not clicked, meaning if you're not buckled, the indicator should go on. So that indicator so that indicator should go on. Indicator should go on. So do we need a separate buckled itself can act as an indicator? What do you think this is? What do you think this indicator is?
Again, I think it should be a boolean. It will be either on or off. Only two things exist for an indicator.
Okay.
Right?
Okay. So private boolean seat belt indicator.
Okay.
Yeah.
Yeah.
Right. Okay. So you'll have that true means it will beep 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 like that, right? At any point. Okay. If car is started and not moving, seat belt is not required. When car is stopped, the indicator should be off. What kind of, are we done with the state information, or we still want to go ahead?
Yeah, I think we are done with the state information.
We are done with the state. Good.
Yeah.
So now, what are
Or
the,
if you, as you said at the beginning, only if we change the gear, the indicator will be on. That if we want to include that, otherwise, I think we are okay.
if we change the gear, huh?
No. Yeah.
Yeah, you can definitely, that's a great point. So you can rely on changing the gear, or you can rely on the current speed. Let's say this car, the way it works is, it will intelligently check your current speed. If you're going at 0, meaning if you're stopped, then seat belt is not required, right?
Okay.
Okay. First of all, we also need to find out if it is started or not, right?
Yeah.
Right? Do we have an attribute to take care of that, to hold that value? No, right?
No.
Okay, tell me what type is that? Agree?
Yeah.
It will tell you whether the car is in started mode or no, running, whether it is running or not, right? You want to use started or running, whatever is that.
Anything is fine.
Anything is fine. Okay, let's say running. Now tell me, before we go to the methods, now tell me, do we need constructors here?
Yes.
Okay, what is the constructor?
For make, model, and win, we need constructors.
Make, model, and win, we need a constructor. Why not running and current speed and buckled and seat belt indicator?
Because the user should have access to it.
User what?
I mean, it cannot be defined at the.
Go ahead. It cannot
like
be
once
defined.
we set it, once we set it as a constructor, then we cannot change it, right? Like the model, win, and make. But here we are going to.
No, that is not correct statement. Even though, as part of the constructor, what are you doing as part of the constructor? You are initializing these instance variables. You are providing the initial values, but you can definitely change them. I can provide a method set make and set model and set win. Then I can do it, right? With the setter methods, I can definitely change them. but are we going to,
Yeah.
do we want to allow the user to change make, model and VIN after the car is created? And do we want to have a user pass whether it is running or not, current speed or not, buckled or not, seat belt indicator or not, these at the time of creation of the car? No. These are not the attributes that are needed at the creation of the car. These are the attributes that you need at the creation of the car. These need to be initialized. And also you do not want to provide any setters for these three, because you don't want your make to be changed once it is constructed. You don't want your model to be changed once it is constructed. You don't want your VIN to be changed once it is constructed. Agree?
Yeah.
Are we on the same page so far? Everybody?
Yeah.
Everybody. Now, I'm going ahead and creating the constructor here, using the constructor. So I'm using make, model, VIN. I'm not using any of this. Very good. Now we got the constructor. And now, anybody may want to find out what is the make, what is the model, what is the VIN, right? But we are not going to have them change these values. So no getters at all. Okay, sorry, no setters at all for these three. And let's say these four also we wanted to, let's not give them the setter methods. Let us give them the getter methods. Meaning anybody can So anybody can find out what is the make, what is the model, what is the VIN, whether it is running or not, what is the current speed, whether it is buckled or not, whether the seat belt indicator on or not. Agree? Yes. So we can safely provide all the getter methods.
Yeah.
Generate getters and setters, select getters. So we are providing. And by the way, for Boolean values, okay, the convention is using either is or has. That makes sense. Rather than saying get buckled, we are asking is buckled, meaning are you buckled? Is seat belt indicator, meaning is seat belt indicator. So probably seat belt indicator probably is bad, but let's say is seat belt on. Okay, is seat belt on. So return seat belt indicator, buckled, get current speed, is running, get VIN, make, model. Now tell me that now let's talk about the real behavior. Now you tell me what is the real behavior? What is the first behavior that we should talk about?
Start.
Good. Should it be a public method or?
Yeah, default or public.
Default or public. Okay, at this point doesn't matter. Let's say public because anybody can start it. Okay, it is not a utility method, only can be used by this particular classes within this package. No, anybody can do it. Okay, what is the return type? Void start, right?
Yeah.
Okay, tell me now what do we want to do here? Probably you wanted to say with this make, okay, like a Toyota Camry, okay, is starting. Okay, now tell me what do you want to do here? Now the real logic, this is just a printing here, this is not the real logic. Now you tell me the real logic inside the start method. Now this is where I want you to provide me the real code. Tell me.
Okay.
Think through the requirement.
Then I'm stuck too.
Exactly. No, think. I need anybody else.
Yeah. What?
When you start, okay. What exactly do you want to do it? When you start, first of all, your running flag should be, once you start, do you want to put it in running?
Yeah. No. It should be on at least. It should not be.
What do you mean? This is like a running, maybe a bad, if you think it's a bad method, then let's change this to bad field, then let's change it to started, right?
Okay.
Then we can provide a getter method for this guy. Is started. Okay. Now tell me, in the start method, should we update this? What is the value of started here? If I print started, what do I get, Uma?
False.
Exactly, because it gets initialized to false. Now tell me, should I change that?
Yeah.
Why? Why?
Because only if it is true the car can be.
Because your start is successful. Your functionality of start is nothing but you ideally should call the engine dot start if there is an engine method, and then you just say started equal to true. If engine dot start fails for some reason, then you don't want to make this true. Rather, you want to change this to false. Are you with me? Do you agree with that? But
yeah.
Since we don't have engine object here, so I'm directly making it as true. So started equal to true. Now, do I change the current speed?
Right now, no.
Good. No. Buckled?
No.
Anything to do with the seatbelt indicator?
Yes.
What is that?
It should be on. Like the seatbelt indicator, when the car is started, the indicator should be on because the seatbelt is not clicked yet or the buckled yet.
Do you want to provide that way? Do you want to, the moment you start, you want to go beep, 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 like that? Do you want to go like that? Or
no.
What did we discuss? Depends on the current speed. If the current speed is greater than 0, then we want to do it, right?
Yeah.
At this point, what is the current speed? It's 0. Do you want to go beep, 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 beep? If the requirement says that is the requirement, then we should definitely do it. Don't get me wrong there.
Okay.
Agree?
Yeah.
So even buckled, I think at this point, no. Now tell me what is the next functionality?
Like we increase the speed or.
Okay. Tell me about around this one, around this buckled. When does this buckled equal to true?
Yeah, when we start the car, actually, when it is moving, that's what you said, right? When it is moving and still it is not buckled.
Forget about the indicator, Ma. But I'm saying when does this buckled equal to true happens?
When current speed is greater than 0.
Yeah.
No, I mean, does buckled get automatically be true? Yeah. I mean, does buckle up happen automatically?
No.
Then how?
You have to click
when the current
button.
speed is greater than 0, does your car automatically buckle you up?
No. We have to buckle.
So what do you need to do?
Do we need to put a separate method saying buckled?
Buckle up,
seat
right?
belt or something. Yeah, buckle up. Okay.
Buckle up, right? So public void buckle up. Agree?
Okay. Yeah.
When anybody can do a car dot buckle up, right? Once it is, even when it is stopped, you can definitely do it, but it's not required. The indicator will not go on. So what do you need to do in buckle up? Tell me.
Should be true.
What is true?
Buckled is equal to true.
Good. Buckled equal to true. And what else?
Indicator should be off. I don't know.
Fantastic.
I'm not sure.
No. You are you are to the dot. Exactly right. If at all the seat belt indicator currently is on, the moment you buckle up, that has to be off. Exact. Super good point. Your seat belt indicator should be turned off because you buckled up. You buckled up, you indicated the system, because maybe somebody else, maybe the start guy, if you try to accelerate, maybe you will not accelerate. If you want to provide that functionality that, hey, I'm trying to accelerate, but without you buckled up, maybe your car does not, let's say you are designing a very safe car, which does not move without buckling you up, without you buckling up. Shall we do that? Shall we add that requirement to the functionality? That's a beautiful car, right?
Yeah.
People would love it. Agree. So when we buckle up, when we set this buckle up function, buckled equal to true and the seatbelt indicator is false. Exactly. Because the seatbelt indicator may be currently true. Who knows? Are you with me?
Yeah.
Right? Okay. Now what is the next method? What is the next method? Anybody? Doesn't have to be Uma.
Yeah.
Anybody? Pitch in, please. She just started.
Like we
That's
have
how. It doesn't have to
started
be
the
her.
car,
Uh-huh.
and are buckled up. So if the car is running, we have to check whether once the car is started, we have to check whether
Go on.
the indicator is on or
Do you want to check at the time of
when
start?
No, we can introduce another method, accelerate, and within that we can write the code.
Exactly. That's definitely a way to do it. You agree, Uma?
Yeah.
So public void accelerate, or maybe what do you think is the return type for accelerate?
Speed. Oh, return type of sorry, it's int.
What is that int? What does it return?
The speed.
Current speed.
Current speed. Good. Okay. So now tell me, in accelerate, does it take any parameters?
Yeah.
What is that?
It takes speed.
Okay.
Int.
Int speed is speed could be new speed, or speed could be by how much? Currently you are going at 50. Do you want to take go 20 more? Is that what you wanted to take it? There is no right or wrong here. Understand?
No.
What do you want to do it? Tell me.
It's
I don't know
the speed that you want to go on. So
the speed that you want to go on. Desired
yeah,
speed.
the desired. Yeah.
Okay. So you directly go on desired speed. Okay. That's definitely one way to do it.
But here I'm just checking whether it is started and whether it's moving, right? I don't want to go to 50 and then realize that I haven't buckled up the seat belt. I just, like, soon after I started the car and soon after I start moving, I should know it, right?
Okay. So
I don't know how this accelerate is helped.
no. It helps you. It helps you. I'll tell you. So let me, whatever you just said in English, right? Let's put it in the same in the requirement way. So what you're saying is, when car starts to move, how does car starts to move? One of the ways is he will accelerate, right? So far, this is the this is the only way that car can move, right? This is actually car moving here. So this is the right place to check if the seat is buckled or not. So if its desired speed is greater than 0, now you tell me, right?
Yeah.
If you want to go desired, obviously if your desired speed is greater than 0, then what do you want to check?
Whether it is buckled up or not.
Exactly. If your desired speed is greater than 0 and not buckled up, this is not buckled. There is this not operator here. This is called not. So if the buckled is true, then this is not true is false. If the buckled is false, this not is true. So meaning if it is not buckled, are you getting it?
Yeah.
Okay. If desired speed is greater than 0 and not buckled, then what do we want to do? What do you want to do? He wants to accelerate. He wants to accelerate at 5 miles per hour or 50 miles per hour or even 1 mile per hour. What do you want to do? One.
It should indicator should be on.
Exactly. So the indicator should be on. And do you want to still continue? Do you want to change his current speed to desired speed so that car will move on? Or what is your requirement? You do not want to change your current speed, right?
Yeah.
Agree?
Yeah. So current speed should be 0 or...
Right. So, in fact, your current speed, you want to make it, explicitly make it. Yeah, I like that. Explicitly make your current speed to 0. Meaning, even somehow, if the car is going at 20 miles per hour and he wants to accelerate 20 more, at that time we realize it, we immediately bring the current speed equal to 0. Agree?
Yeah.
And then we will return just the current speed, right?
Yeah.
Right?
Yeah.
Okay. Not really. But what happens?
No, here you had to.
What
else
happens?
condition.
Exactly. There should be an else condition here. So if the desired speed is greater than 0, okay, and not buckled, you want to do this one. Else. Tell me else. Uma, you tell me. What do you want to do in else condition? Tell me. Meaning, if he is buckled, he wants to do either greater than 0 or, buckled. Tell me, what do you want to do now?
Yes.
You want to change your current speed,
right?
right?
Yeah.
You want to change your current speed equal to your desired speed. So you are making his desired speed as the current speed.
Okay.
But is there a defect here? Okay, first of all, did you understand this, Uma? This else block?
Yes.
No, speak up. What we are doing here is that if your desired speed is greater than 0, meaning if you want to drive and not buckled up, we are saying seat belt is on and then we are bringing down his car, we are stopping his car. Otherwise,
Other seat belt indicator should be false, right?
Okay, else, good. Seat belt indicator should be false.
False.
Good. Exactly. So your seat belt indicator should be false and then,
And do I really need to mention the current speed is equal to desired speed there?
Otherwise, he wants to go, see, his intention is not about seat belt. This is your safety check you are doing it. He wants to go. He wants to move the car. I want this car to move at 20 more or 20 miles per hour. If you don't change your current speed, then you are currently going at 0. Then even after accelerating, you'll be going at 0. Is that what you wanted?
Okay.
Are you getting it?
Yeah, got it.
But there is actually one defect. Can anybody tell me?
Yeah, here you can make
current
condition different.
Current speed is desired.
Yeah, say that again.
I think
One of you.
I think too many people are speaking. So current speed is equal to current speed plus desired speed, because the method that we are calling is accelerate. So if we happen to call the accelerate method twice or thrice, we need to preserve that current speed value so that
So what you are saying is, this is not the desired speed then. This is by how much? How much more? Currently you are going at 20, and can you increase by 10 more? Can you increase by 20 more? Is that what you are saying?
yeah, so just maybe just say how much, whatever that we want.
Okay, if that is what it is, then I'll bring up another point. Did you understand this, Uma? By how much?
Yeah.
Currently you are going at 50, and if I accelerate 5 more, then that's when I'm checking. But is this correct? This is not correct, because the initial requirement was different. Jyoti just changed it. That's fine. But now we need to check what is your current speed. If your current speed is greater than 0, okay, or
Yeah.
first of all, let's do this one. Let's do a desired speed, okay? Your desired speed is nothing but your current speed plus by how much, right? You want to go, you are currently going at 50 and you want to go at 20 more miles per hour, then 50 plus 20 is your desired speed, right? Now,
Yeah.
if your desired speed is greater than 0 and not buckled, then you are saying seatbelt indicator equal to true, and then you are bringing your current speed to 0, meaning you are stopping the car. Are you with me?
Yeah.
Or you don't have to do this one really. Let's write a different method called stop. Public void stop. Okay? What do you want to do in your stop stop method? Tell me.
Yeah. Just stop the car.
What do you mean?
Started is should be false.
Exactly. Started equal to false. And then
False.
what else? Think. When you stop the car,
Seat
what
indicator
happens?
should be. The speed is 0.
Exactly. Current speed has to be 0. Okay. That's it.
And the indicator should go off.
The seat belt indicator should go off, right? When you stop the car, absolutely. That should be false. Now, tell me what is your goal here? When somebody is trying to accelerate, okay, if his desired speed is greater than 0 and not buckled, then we are saying the seat belt indicator should go on, and then you want to stop the car here, right?
Yeah.
Right?
No.
Yeah.
Exactly. You want to stop the car, right?
Mm-hmm.
No. Why?
Oh, you
Why
don't
to
want,
stop the car?
you don't need to stop the car. Actually, you just say you just bring.
You can
the
call
current-
the buckle up method.
No, I mean, how can you call the buckle up method automatically? Rather, you want to bring it down to 0 miles per hour. Agree? You want to bring it down to 0 miles per hour, meaning you are literally stopping the car. You are not actually shutting off the car. This is actually shutting off the car. Okay? But here
Yeah.
you are not actually stopped. It is still running. It's still in started mode, but you are bringing down the current speed to 0, meaning it will not be moved anymore. It will not be moving. Are you with me?
Yeah.
Okay. If desired speed is greater than 0 and not buckled up, then this is what you're doing. You are essentially making the car not move. Okay. Otherwise meaning either your desired speed is 0 or you are buckled up. Then you are saying your seat belt indicator should be false, and then now current speed equal to your desired
Whatever
speed, right?
speed. Yeah. Yeah.
Your desired speed, right? And you are returning your current speed. But still there is a defect here. You know what is that?
Yeah.
What that one is?
Yeah.
You are not checking with the maximum speed. Because now, if I'm going at 100 and I'll say that, hey, can you accelerate by 100 more miles per hour? You are doing it. Ideally, you should check with your maximum speed also. Are you all with me? Agree?
Yeah.
Agree? So ideally, your, what is that called?
We are given maximum speed equal to 140 or
Exactly.
something.
Exactly. Maximum speed equal to 140. Okay? And do we want to take this as part of the constructor? Probably not. Not probably. No. Absolutely no. The reason is, otherwise, every car manufacturer will bring their own maximum speed. No. This has to be provided by the template. Okay? That is why I initialized here. Now, now check here, the seatbelt indicator is false. Now, here we are checking here. If, okay?
Yeah.
If if desired speed is greater than maximum speed, okay? If desired speed is greater than maximum speed, then we are making your current speed equal to
Max.
Desired speed.
maximum, maximum speed. There is a typo. So it doesn't matter how much he wants to go. You are putting here his current speed as 140 because that is the maximum he can go. Else, okay? Else, now you are saying your current speed is desired speed. Agree? Is it so clear? Did you get this, Uma?
Yeah, yeah.
You're still not getting it?
No, I understand the concept, but just I'm thinking how I should think to get those points. That's what.
No,
Yeah,
that's not
okay,
what we
got
did
it.
now. I mean, we are thinking through the points and then.
Yeah, yeah.
No,
Yeah.
is this what you were actually asking me? Let me start with that. Is this what you wanted me to do it or something else?
Yeah, exactly. See, when I start, for example, if I had started working on this, then I don't know how to proceed. For example, you said that to check whether the seatbelt is on or whether the seatbelt is buckled or not, you have to put that inside the accelerate method. So
This is
likewise, and then
this is purely based on the requirements that you gave it to us. So we did not make up anything, right?
yeah, that's what I don't know how to bring that requirement into the programming.
Agree. That takes
that-
practice. Don't worry. You are in the beginning days of
And
it.
Venkat,
You are in the beginning days of it, right? We will get there. There is a shortcut for that. Practice.
Venkat.
1 second, huh?
Yeah.
Just do it, undo it. That's it. You keep doing, Uma. If 10 programs did not give you that comfort, write 20, write 30, write 100. That's it. You will get it. Don't worry. We are in the very starting days of it, but are you getting it?
Yeah.
Okay. So that's it. Pretty much this one is done. You can actually write the demo and then see. You can try to go if you're. We can do, especially from the buckle perspective, we can do it. Yeah. Someone was speaking. Madhavi, I think I stopped her.
No,
Sorry.
it's me, Aruna.
Aruna, tell me.
Just in that else spot, maybe you can call the buckle up method and make that, you can take out that indicator, the one you made it false.
Oh, this one, seatbelt indicator equal to false. Okay.
Because you can call the buckle up method.
No. I don't want to buckle up exclusively, right? Buckle up should only be called by external people.
See,
I know what you're saying. I know what you're saying. You can achieve the same thing by calling the buckle up also. So just say that buckle up, so that buckle up will be true, and then
Indicator will go off.
So because we are going with the else, so we used not buckled up. So if it goes into the else, it means that it is buckled up.
exactly this one condition is already true. So we just need to do this one, I would say, right?
Correct.
It's already there, Aruna.
Okay.
But I see your point. I see what you're saying.
Yeah. Okay.
I wanted to actually use this.
And also it's the logic.
I mean,
So if both
No.
are true only.
I get it. You get the same behavior. Did you understand, Uma, what Aruna is saying, or everybody else? So what she's saying is, you can not only write the statements in a method, you can call other methods too. In fact, I was trying to do this stop. If it is not buckled, I wanted to call this stop method, but I realized the stop method means it's completely turning off the car. I don't want to turn off the car if it's not buckled. I don't want to move the car if it is not buckled. Okay. So that's a good point. Now car equal to new car. Make what's your favorite car?
Anything is fine. Maybe we can create a new car. Logic.
Porsche Cayenne, I think it's correct or something. I'm just going with fancy cars just for the sake. Okay. Now, this is the car we created it. And now let's try to See, let's start the car and then let's move on. Accelerate 20. Okay. See, we did not put the buckle, right? We did not buckle up, right? So now you want to look at what speed you are going at. My current speed equal to, in fact, car.accelerate will give you that. Okay. Let's go. Let's do this one. Car.accelerate like this. Okay. I'll just directly call this one. So did you get this point? I'm calling the method here itself, and whatever is returns, it will get printed here. I started and I'm going at 20 miles per hour, and I wanted to find out what would be my speed. Okay. Porsche Cayenne is starting, my current speed equals 0. Why? I'm going at 20. Why is this so? Can you tell me why? Let me do it differently then.
Here, I want to say buckle up or something.
Yeah,
No, so
we'll get there. We'll get there. I'm writing here. Int current speed equal to car.accelerate. I got this one. So what I wanted to do here is that I wanted to show my current speed, and I also wanted to show my buckle up indicator. Sorry, my seat belt indicator, right? Seat belt indicator equal to car dot is seat belt indicator, no, is buckled, is seat belt indicator on. Okay. See this? I started the car. Even though I accelerate, I wanted to go at 20 miles per hour. It did not go a bit. It's not moving. The car is not moving. It's going at 0 miles per hour, but my seat belt indicator is on because I did not buckle up. Now let's start the car. Okay. After starting the car, let's say buckle up. Or you tried accelerating. It did not go. Now what we'll do is, let's say car dot buckle up now. Okay. Now try to go car dot accelerate now. Okay. Now let's try to go to 20 miles per hour again. So initially I tried to press the gas at 20 miles per hour, but it did not go because my seat belt is because I'm not buckled up. But now I'm buckling up and now trying to go at 20 miles per hour. Now let's try with my new speed is int new current speed. Okay. Now print it. Now you take a look at it. See, Porsche Cayenne is starting and tried to accelerate at 20 miles per hour, but it didn't do anything. Just my current speed is 0 because my seatbelt indicator is true. And my current speed equal to, now I buckled up and now I try to accelerate. Now I'm going. In fact, do you want to look at the seatbelt indicator now after buckle up? Now we'll take a look at it. See, now the seatbelt indicator is false. Clearly showing you. Okay, does it make sense? Everybody got it? What we are trying to do here? Uma, mainly, did you get that? Because you asked this question.
Yes.
Is this what you are trying to get out of me?
Yes. Basically, you told me the shortcut, right? So I have to work on that shortcut, I think.
But maybe your question is, hey, you are able to code well. How come I'm not able to? Probably that's your question, and maybe it's everybody's question. Watching video is fun and easy. You think that this code is piece of cake. I can do it. This guy is doing it. But once you start typing, that is when your hands don't move. You can't type You can't type because you don't understand. Okay, it happens, and we are in the first weeks of the training. So don't worry at all. Don't worry. But there is a shortcut, as I told you. It's a practice. Just practice, 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 and practice, you'll get it. That's it.
Okay. Okay.
So there is no shortcut, is my point. Okay.
Yeah. Okay.
Any other questions? Did that help at all, or?
Yeah, it definitely helps. But yeah, once again, see, even though I practice, I should be able to get in what other ways I should work to get the result, right? If I'm for the first time, if I'm getting it wrong, that's fine. But the second time when I try, I should be getting more ideas. So you say that it will happen by practice, right? That's what I want to know.
I think so. I don't have a straight, book answer for that. Honestly, I don't have an answer probably.
Because to be very frank, if I had tried working on this problem, then I would have not definitely thought about this, or at least the way you worked on within this accelerate method. Like within the accelerate method, you are trying to connect all the dots. So, and you're getting the results, right?
Because we need to think through that, right? I mean, what and all happens? No, see, Uma, this is nothing to do with the code. That is where I'm going, I think. Anybody and everybody can pitch in to, this is not a technical question, so everybody can pitch in and give your ideas. But my point is, not really a technical, so what we do is, at accelerate, what and all should happen? What is it trying to do? Well, he needs to be able to go. He's currently going at 50 miles per hour and he wants to go at 20 more miles per hour. So we need to increase his speed. Okay, so we need to increase his current speed. That's the first thing. And before that, actually, he wants to go at 70 miles per hour. Agree. But if he's not buckled up, I don't want to go. That's my requirement. So let's code for this requirement. Well, if he's buckled up, then what do I want to do? Then since he's buckled up, I want to turn off the indicator. And then does he want to go more than the maximum speed? If so, then no matter how much he wants to go, he can only go at 140 miles per hour, which is our maximum speed.
Yeah.
And then finally, I want to return whatever is the current speed. So it's just a plain simple English, right? I mean, it is not. I agree. I'm not really. I'm not really. I don't want to lowball this, but that's what it is, right? While we speak, we wrote. And how do I get that thinking as like me? There's no shortcut. It's a practice. Anybody else can pitch in, and any other people want to add something? Okay.
But this definitely helps. Yeah, at least I will start thinking through those lines.
I mean, I was hoping that's what you wanted to,
Yeah, definitely. Yeah.
If we do want, so same thing. Did you guys try doing yesterday?
Actually, yesterday in the collaborative session, we just took a simple example and then discussed about what could be the input, what could be the output. Jyoti and Ravi, everyone was guiding. So if we want this as a return, what could be the input or what could be the output, like accelerate and speed. That's what we were discussing.
But this one is little more coding, right? We were doing little more coding, little more involvement with.
Yeah, there also we wrote the code, Venkat. We showed we worked on the like deposit, withdraw, and we calculated the interest. So we wrote the code, then we changed our views. So it's also going, but since you can explain better than all of us, so I think she would be more comfortable.
We thought like we need to have some scenario-based questions where we can convert that particular scenario.
Yeah.
The way you mentioned the requirements, right?
Right.
So that everyone can change that scenario into a code and come up with their ideas. It's nothing like one should have the same code. It's just like an assignment.
Yep.
We go through in our masters, right? That's
exactly.
The same. They just give us as a scenario.
I got it. I really like it. Yeah, we can hear you.
Sorry, yeah, that's what we thought, and it's just like an assignment, so that it's nothing like everyone can have their own can have their own code. It's nothing like
Exactly.
It's like a plagiarism. No one should copy, right? That's what we think. Everyone had different codes, and then come up with new ideas and share it off. That's what we
Can we
thought,
do
and
then more requirements? This requirement with the seat belt is fantastic. Uma, thanks a ton for that.
Yes.
You know, this is not as easy as I was saying, as I was taking the other day, simply if it's maximum speed, etc. It's little more involved. It's not really complicated. It is not so easy. So it's somewhere in the middle. We're putting more. So can you bring up more points like this, more requirements like this, and then let's have our friends do everything. And when you guys meet, that's what you should do it. You know, you come up with the requirement and then do it more coding.
I have no problem bringing up the requirements. The complicated part is the logic for me.
Right. That one.
Anyway, yeah, I will work on it. I will work on it, and then
Yep.
And
even
do
I'm
you
trying
have
to
a
gather
place
few.
wherein? Yeah, sorry. Go ahead, Ravi.
I'm sorry, even I'm trying to gather some few scenarios, and yeah, I got like few examples. I'm just searching here and there, and so that we can work on that in our collaborative sessions.
Yes.
Fantastic.
You could give us some.
And I have sent you like few PDF documents where there are like more examples which you can work on together, everyone. Like same scenario based questions.
Very good.
And that is one point, and I have one more thing. Like, can you, I don't know whether this is the right time to ask, but in the collaborative session now I think we can work on these requirements. But earlier I was thinking that we can take one specific example, or or a car or a laptop or anything, and then as you teach us the different concepts, we can keep adding and implement those concepts in that example.
Yep. In fact, we are in the very early on stage actually. I myself will start doing that very soon. Okay. But you also bring up those points. You know, this one is really good. The reason I like this is because it's not complicated. And it's simple, but it's not as simple as my previous accelerate method where I'm only looking for maximum speed. So it's a little bit more. You know what I'm saying? It's really good. It's really good. That's why I liked it.
Okay. Thank you. Thank you so much, Rangit. Thank you for spending the time and explaining everything.
No problem at all. No problem at all. You know.
And thanks everyone for allowing us to work on this. I mean, everyone must be expecting different topics for the class, right? So
it's important. I think this really helps everybody. You know, how to write the code and how do we translate the requirements into code. Definitely, I can understand, you know, a lot of the people came into programming for the first time. So, no problem at all. Okay.
Thank you, Rangit. Thank you so much.
No problem at all. Yeah. So, if that's all the questions, or anybody else has any questions, shall I start on the new topic? Okay. So, in the last class we talked about this object-oriented principle called encapsulation or data hiding. We learned that whatever needs to be hidden should be hidden. So not everything needs to be exposed to the public, to the outside of that particular class or outside of that particular package. So, and we have taken some concepts, some examples. In car, when you start the car, there's so much going on, but all of those object interactions and everything is not being shown. So you don't need to actually take the two wires and then combine them to be able to start your car. You don't need to. You have a fancy way of starting the car. You just put your key and then turn on. So that is the top level interface, the high level interface. That's how you want to design your objects. So think of it. There is so much hidden there in the car example. You're only seeing the outside one. So always think when you design any object, think that should this be exposed or should it be private? All the private stuff should be private. Keep them as private. That is called encapsulation or data hiding. So that's one of the object-oriented programming principles, and the other one is called inheritance. So in inheritance, what happens is the relationship between two objects now come into play. Meaning, let's say that all the animals, let's say I have these objects like dog, cat, and cow. Okay, we have three animals. If I need to design a dog class or a cat class or a cow class, what do? What are some of the attributes or state information? So you have number of legs, right? You have the legs, and then hands maybe. Hands could be 0 for some of them, but depends on it. And height, age, etc. Okay, height, age. These are all the attributes of the animal. An animal can have name too. This is all the state information. If I need to design a cow, probably I'll put all of this. And then if I need to design a cat, I'll take the same name, legs, hands, height, age. I'll do the same thing with dog. Okay, and then some behavior is like a walk, eat. Okay, probably there is a method called milk. Okay, you can milk a cow, right? And here when it comes to cat, you may have you will definitely have a walk, and you will definitely have eat, and then you may have like run. That could be specific to cat, and then maybe some other methods, right? And in dog also, dog can walk, and dog can eat, and dog can do like something like a fetch. Okay, dog can fetch the things, and dog can do some other things. Now look at these three different objects, right? Now if you look at these three different objects, every animal here has a name. These properties are common. All the common stuff I'm putting here. The name, number of legs, hands, height, age, right? I'm sure cow may have some specific attributes, and cat may have some specific attributes, and dog. But these are all common stuff, right? And then the operations, when it comes to operations, walk and eat, these are common across all of these animals. So if I ask you to design dog, cat, and cow, you will end up duplicate all the state information here, 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 and you end up duplicating all the behavior information in all these three of them. Now, if I ask you to design one more animal, probably you will duplicate all of this. When something needs to be changed, then you have to change. Let's say we want to change the way animals walk. All the animals are walking one way today, but let's say we change something. Okay? And then we have to change in every single class. That is why you don't need to do that. That is why we can use this concept, object-oriented principle, called inheritance. In inheritance, what you can do is you can design a different object called, in this case, animal. Let's say animal. Okay. Now keep all the state information that is common across all the animals in your animal class. Keep all the behavior information that is common across all the animals again in animal class. And using inheritance, you will automatically get, you just say that dog is an animal. You just say that using some syntax in Java or any other program, other object-oriented programming languages also, you just say that dog is an animal, meaning dog is a child of an animal, the parent and child relationship. With that relationship, once you establish relationship, you do not need to duplicate all of this information here. You will automatically get it from animal. Same case with cat. You just say that cat is an animal. You will automatically get all of this behavior that are common across, and you will also get all of this state information. Again, you just say that cow is an animal, and then you don't need to define any of these state information, and also the behavior information. The common state and common behavior information, you will automatically get it from animal. Let's say the milk. You don't get this milk because milk is specific to cow. You need to put this one in your cow itself. You need to put this one in your cow itself because this is specific functionality of cow. Cat does not milk, dog does not milk, so you want to put this one only in cow. So this one, we are not going to put it in an animal object. Not every animal can milk. But every animal should be able to walk. Every animal should be able to eat. So those two behaviors, those two methods, you can safely put it in animal class. And just say that this class or dog is an animal. That's it. You will automatically get it. So what are you saving here? Well, you don't have to duplicate all of the code in all these objects. You just put it in one place called animal. And let's say tomorrow you are saying that, hey, you know what? All animals are able to eat and walk today, and all animals should be able to jump also. Let's say there is a requirement. Okay. Then you don't have to add to cat, dog, cow. You don't need to. You just put that operation in your animal, and every single object will automatically get it because all of these objects inherit from the top level class called animal. They are inheriting, like how we all inherit certain attributes or certain behavior from our parents. Here, dog is a child of animal. So animal is a parent object for all of these child objects. So dog inherits from animal, cat inherits from animal, cow inherits from animal. So the moment you say that cow is an animal, then you will get all the state and behavior information automatically into cow without having to duplicate it. Okay, tomorrow, let's say that you have one more object here called elephant. And then elephant is also an animal. You just say that elephant is an animal and you automatically get all of these properties and you will automatically get all of these behavior information. This is called inheritance. Okay? And this is true for every single object-oriented programming language. I'll just show you the same concept with an example, but I can take the questions. Anybody has any questions at this point? Let's take a look at the example. So I'm creating a new package here. Com Java Venkat training Java core inheritance. So I'm taking the same example here. Let's say animal. So first let me design the top level animal class, right? The parent class. So I'll say that, can you say any behavior information? I'll start with the behavior here. Public void walk. Okay. I'll just say animal walking. You can jump in. Anybody has any other thoughts? Public void walk eat, right? Animal is eating. Okay. Now let's say name. So every animal should have a name. So string name. Now you may be wondering why I'm not putting private here. The moment I put private here, I'm not saying good or bad at this point, but the moment I put a private here, this name is going to be visible only within that particular class. So we'll look at more complicated and what is the right way to do it. I'll explain later. But the moment I put private, this is only going to be visible within the animal class. Even though your dog is a child of animal, even dog will not be able to see it. So I'm removing private for now. So I'll put it as a default, meaning every class within this package can access it, but I'll show you how the subclass automatically gets it. So name, age, int age, height, let's say double height. Okay, and what else? That's it, right? You can also say height. No, we said we can say number of legs. Okay, you can say number of legs. Okay. And now, that's it. Now do we want to look at dog? Let's create a new dog class now. So public class dog. Now I want to say that I want to get this state information and behavior information automatically into dog, because every dog has a name, every dog has age, every dog has animal. Sorry, every dog has height, every dog has number of legs, and every dog can walk and eat. In fact, they are an animal. That is the reason they are an animal, because every animal can do it. And the inheritance relationship is shown in Java. Public class dog, there is a keyword called extends and then animal. That's it. Just by saying, you will be automatically be able to call these methods. You'll be automatically be able to use this state information. That's it. All you have to do is dog extends animal. Automatically you got all of this state information, you got all of this behavior information into dog. Okay. So this is with the dog. And now, what is the other one? The other one is the next object is cat, right? just say that public class cat extends animal. That's it. You will automatically get all the attributes, all the state information and behavior information. And the next one is cow. Public class cow extends animal. It is that simple. Now I'll show you with the demo class, animal demo. Let's get the, or we can say inheritance demo actually. See here, dog equal to new dog, right? Now see the magic here. Dog dot age, you can set the age, you can set the age, height, you can set the name, you can set the number of legs, you can say dog dot eat, and you can say dog dot walk. Hey, how come it got all the methods, and also you can say dog dot name, right? Dog dot name equal to whatever, Tommy, and dog dot age equal to 5. Okay, how are you able to do it? Now go to dog class. We did not define name or age attributes, and we did not define eat and walk methods, but how are we able to do it? Well, that's the inheritance magic. Just by saying dog is an animal, this extends keyword does the magic. Get it? And look at the same thing also. Cow equal to new cow. Cow dot name equal to any good name for cow? Lack of better name. So cow dot age equal to 1. Okay, and then cow dot anything else, age, height, number of legs 4. Cow dot height equal to 5.6. I don't know what it is, but, or let's say, yeah, 5 feet 6 inches, let's say. Okay, and now you can say cow dot eat, cow dot walk, without you having to do anything, without defining anything. You are able to do it. You have never seen this behavior, but you're able to do it thanks to inheritance. And in addition to what you get from animal, you can definitely define your own methods in the cow class that is specific to cow only. You can add the attributes that are specific to cow. Not every animal possesses, but you can add specific behavior and specific state information of cow in your cow class. You can definitely do that. What did we say earlier? Milk. So public void milk, right? So only dog can milk. Only cow can milk. So now we are saying cow is milking. Good job. Agree? Now take a look at it. Now you can do cow dot milk as well. See? So my point here is that just by saying your subclass extends your base class. This is also called your base class or parent class, and this is called your subclass, okay, or child class. So just by saying your subclass extends superclass, you will automatically get the behavior and state. You will inherit them from your parent. And take a look at it. See, animal is, see here, what is getting printed here? Animal is eating. So when you call the eat method, it is calling the eat method in animal. Obviously, there is no eat in dog. There is no eat in cow. See here? But when you say cow is milking, when you call this milk, it is actually calling from the cow's class. Get it? It's pretty sweet, right? So in addition to what you inherit from your parents, or you're from parent, actually you can't extend more than one class. We will talk about that later. So you cannot have more than one parent. Okay? But in addition to what you inherit from your parent, you can also have your own state, your own behavior. Any questions at this point? No?
So if we declare as public in the animal class, we will not be able to use this extension, right? Sorry, private. If we use private in the animal class,
Okay, we'll get there.
declaring the variables.
We will get there. So
Okay.
what you are saying is these variables, right? Now that's my next point.
Okay.
Before that, any other questions? So now the next point is, in encapsulation or data hiding concept, we talked about the blind rule. The blind rule of thumb is that every single attribute in a class should be private no matter what happens. Okay? Otherwise, if there is any other class inside this package, they can come and change it. We do not want to, right? So let's make them private. No problem. So let's make them private. The moment you put them as private, they are not visible to dog class, they are not visible to cat class, they are not visible to cow class. Even though they are children of animal class, once you declare an attribute as private or a method as private, they are not visible outside of the classes, even to their children, period. Okay? So obviously inheritance demo will fail because it says that, I'm sorry, what you're saying, there is no name attribute, or I can't see the name attribute. It's saying its name is not visible. It is not visible to me because it is private. You can't do this one. Okay? So now immediate question is name, age, height, and number of legs. Where do we want to put these properties? How do we want to accept these attributes? What are the two ways of doing it now? I have to declare these variables as private at this point, right? I declared them as private. Now what should I do? What is my next step? How can user provide a name or age, a height, a number of legs to this one? One of you.
Constructor.
Constructor.
Beautiful, beautiful. That's the satisfaction I'll get it. So you all understand that concept of constructor, yes. And can anyone say that setter? Can you change your name of an animal? Probably yes, right? So name definitely can be, you can add a setter method, but it should go first of all in the constructor, or it can go. Should is a bad one. I don't need to say should, okay? Because probably you can create an animal without having a name or age or height and number of legs, and now you can provide the setter method. Set name, there you can provide the name. Set age, there you can provide the age. Set height, there you can provide the height. Set number of legs, you can do it. But let's do it from the constructor. That makes sense. At the time of creation of the animal itself, you provide me all these 4 important attributes. Okay? After that, probably you can change the name. Probably you can't change the height and change the number of legs, definitely. Okay? So constructor. Yeah, definitely number of legs. You don't want to put set number of legs, right? Because once I create the animal A equal to new animal, I'll say A dot set number of legs 4. And then later on I'll say that the A dot number of legs 3. That's a bad idea, right? So we should do it from the constructor to start with. So we got this dot name, this dot age, this dot height, number of legs. And then maybe somebody wants to get what is the age, what is the name, what is the age, what is the height, what is the number of legs, right? So what should we do? Provide the getters. Getters are always harmless. So let us provide them the getters. Now, all of these getters also, they are visible inside the dog, inside the cat, inside the cow now. Okay? But now let's talk about it. Now, fun comes into picture. What is that real fun? Okay. The moment I provided this constructor, my child classes started failing. It is saying that implicit superconstructor animal is undefined for default constructor. So I need to tell you something here. I told you that if you do not provide a constructor in your dog class also, if you do not provide a constructor, okay, what happens? Can one of you tell me what happens? Compiler provides a default no arg constructor. You remember that?
Yeah.
Right? So your compiler provides this no arg constructor like this. Okay? And in each constructor here, you will call, as the first statement, you will call the superclasses constructor. Okay, so this is what your compiler does automatically. Public, dog, and then super. What is this super? We never talked about the super. Well, let's talk about it now. So in my subclass constructor, as the first statement, this is a requirement. This is what your Java compiler says. This is what your JVM expects too. In your constructor, the first statement has to be your superclasses constructor. You have to call the superclasses constructor like this. So your noarg constructor is calling super noarg constructor. But what does it mean? Well, what it means is dog has a superclass of animal, right? Now it goes there animal. Now it is trying to call the animal classes constructor. Well, but is there a constructor in animal class that does not take any arguments? No, there is nothing like that, right? So there is no constructor in animal that takes no arg. But you can immediately say that, hey, compiler should provide that no arg constructor, right? For animal, compiler should provide the no arg constructor, right? How come compiler is not providing this constructor here? Tell me. How come compiler is not providing this no arg default constructor? Any of you?
Because we created express.
Because we are creating once you create constructor.
Fantastic. I'm very happy today. Yes. Because the moment you provided your own constructor, your compiler will not provide the constructor anymore. Your compiler will not provide the default constructor anymore. So that is why it is not providing it. But here, since you don't have the constructor, your dog class, your compiler is providing the dog constructor, which internally calls the super constructor, but it does not have it. That is why it is failing. So in that case, what is the option? Then we have to provide a constructor also. Dog also should provide a constructor. So let's say dog also is providing the same constructor. Okay? Dog is also providing the same constructor, name, int, age, height, and number of legs. And then as the first statement, we should call the superclasses constructor. So I'm calling the constructor that takes my string int double int. So I'm calling the superclasses constructor now. Now this is happy. I can do more also. I don't need to take name, age, height, and number of legs. Probably every dog has, tell me one of those pieces every dog should have it, like how name, age, height, and number of legs. Only dog has. Anything that every dog gets it by birth. Color. So you want to say that, but it's common for all the animals too, right? Is there a way you can think anything? Oh, breed. Excellent, excellent. String breed. Thank you. So now you take name, age, height, number of legs, and breed. Breed is only specific to dog. So you define your own attributes in dog like a private string breed. Okay. So in addition to all the attributes that you get it from your parent, you can also get breed. So in your constructor, you are expecting all these four because every animal needs all these four anyway. I'm calling the super constructor here. You know what it means? Meaning I'm calling this constructor, I'm passing these values. So these instance variables will get set. Did every one of you get it? And now the breed, I'm initializing my dog's instance variable called breed like this. That's it. Get it? Did you get this one? Every one of you, did you get this one? This is the super keyword, meaning you are calling the superclasses constructor. You are calling the superclasses constructor that takes 4 arguments, meaning here you're calling the superclasses constructor. And after that, this is specific. You are taking the breed, right? And now you initialize your breed. And now you can provide the breed also. Obviously, breed is, there is no setter. So you only have getters. Beautiful. Agree? And now you have to do the same thing with cat. Now, cat automatically. I'm doing a control 1 here. See, this is an error, right? It is telling me that there is no implicit super constructor. Animal without any arguments is undefined. For default constructor, must define an explicit constructor, because compiler is providing a default constructor, and within that it has a super without any arguments, and your animal class does not have a constructor that takes no arguments. The default no arg constructor is not there. So we need to provide an explicit constructor. So I'm putting a control 1 here, add constructor. See here, it is automatically adding the constructor like that. Control 1, when you get an error message, just do a control 1 which gives you suggestions. Your Eclipse will give you suggestions. So you don't have to type this one. So what it's doing is, it is giving me a constructor that your superclass has it. Your superclass has this constructor, and it is just calling the super. Like exactly like your dog, if there is something that is specific to cat, you can also take that one. And in fact, you can overload the constructors. You can have this constructor, you can have one more constructor that takes 4 and 5 more. One thing, something like a breed. Something like breed. I don't know what it is, but make sense? You can have this one too. Now let's go to cow. Same thing. Super. And now our inheritance demo is saying that, sorry boss, I don't find, see, why is it complaining? Can one of you tell me without looking at without reading the error message? Because dog does not have a default constructor. Exactly. We do not have, see this one, the constructor dog is undefined. So now we need to provide, what is that? Name, age, height, name, age, height. What is the other one? Number of legs and breed. What's the breed? Anybody knows? Any breed? I'm not sure about it. So now this one, name, age, this one we have to remove it now, right? Now cow. We can do cow. Name is cow. And then age is 1. 5.6. Or is 4? Number of 4. And then there is no breed, right? Okay. Pit bull. Is it a breed? Okay. It's a breed. Apparently. Thanks, Yuri. Wonderful. That's it. Now, in fact, you can enhance this guy now. Now you can say walk. Now you can say who is exactly walking. That name. Okay. Is walking. Name is eating. And then anything else? That's it. Let's look at now. See, Tommy is eating, Tommy is walking, cow is eating, cow is walking, and milking. You can, yeah, that's what we put it. Cow is milking. Did you all get that? This is inheritance. Okay. Now, we talked about the access modifiers. We talked about private. Private means absolutely private to that particular class. So these variables are private, meaning they are not visible outside of that particular class, even for its children, right? Public means anybody can access it. Anybody can access it. If you take out the public, only the classes within that particular classes can access it. That is what the default access modifier. Okay, but there is one more access modifier that especially makes sense in case of inheritance, is called protected. It is called protected. So protected. What this protected means is, even though it is not in that package, even if it is outside of the package, the protected fields and protected methods are accessible irrespective of where they are. They can be in the same package or they can be anywhere else, any other package, but they are visible to all the subclasses, all the subclasses. So all the children will be able to see that field, will be able to see that method. Nobody else can. If there is a protected method in a package, let's say foo, okay, I'm in a different package. I'm in a bar package, phone bar. Now, if there is a class called dog here, or if there is a animal, right? If there is an animal in foo class, and then in bar, I want to have access to the protected method here, then what you have to do, you create a class that extends, meaning subclass of that particular animal class. Now you can see the protected methods and the protected fields from animal into dog. Now your dog can see them. That's all. So if you want to provide the access modifiers, if you want to put them into context or into the point of, okay, private is the more restricted, only within the class. Private methods and private fields are only within the class. Now default or no access modifier are only within the package. Now your protected is little more, meaning more than package. Okay, they are visible as long as they are in the package, and also even if they are in outside of the package, so they're good outside of the package also, but only for, not everybody, but only for children. And public means boundless. Everybody, doesn't matter, every package, it doesn't matter what package it is, whether it is children or not, doesn't matter. Everybody can access it. Everybody can access that particular field or constructor or method. All these three are applicable for field or constructor or method. Make sense? Everybody, any questions? So there is a keyword called protected. Protected. So you're only protecting, you're only giving access to your child classes. Let's say there is a field here called, field that I want to give only to my subclasses, not everybody. Tell me one field. Everybody should be able to see it. Dog can get access to it. Cat can access to it. Cow can access to it. Or let's not talk about, because we just talked about it. Let's talk about encapsulation. Sure. We already talked about encapsulation. So everything should be private. So let's expose a protected method here. Okay, let's say private. Thank you. So let's say private string color, right? Okay, and now I'm going to provide a set color method here. I'm providing both getters and setters here. So you can change the color, and you can also get the color. You can get the current color that is in. But I'm going to say this get color, anybody can get it, but only my subclasses only can get it. Protected white set color. Now you will have access to it. Bug dot. You can definitely have access to it. Make sense? So you have access to it. So that is about the protected. And with the protected, your access modifiers are complete. Now you have 4 access modifiers: private, default, protected, and public, in that order, exactly speaking. Any questions?
I have question.
Yes.
If I will take one animal, goat, and can goat take the method, milk method from
Hello?
the cow?
You broke actually. So you have a milk method, okay? Now goat is a subclass of animal, right? Let's write down.
Yes.
Is that what you're saying? Goat is an animal, right? Goat, right?
Yes.
So goat extends animal.
Yes.
Beautiful. Okay. Sorry. Yeah, goat extends animal. Now you tell me, can this goat have access to milk method that is in the cow, right?
Yes.
Is this your doubt?
Yes.
Okay, tell me, what do you think? What do you think? Let's put it into perspective here. Let me put it into perspective here.
Can
Let's put it into perspective here. We have animal here, right? So we have dog here, cow here, we have cat here, and we have what? Goat here now, right? Good. Now, your goat's dad is animal, cow's dad is animal, cat dad is animal, dog's dad is animal. Now, cow has a specific method called milk, which only cow can get it. Okay, which only cow can do it. You can only milk cows, not anything else. Now you're talking about goat. Can goat get the milk function or milk method from cow? No, because there is no direct relationship, right? Goat gets all the behavior, goat gets all the related fields from animal only, because goat is an animal. But if you say that, let's say animal cow, let's say there is a specific cow. How many types of cows are there? Tell me more. One of the specific cow. What is a cow's kid called? Do you know? Cow kid. Do you know what is the English word for that?
calf?
Okay. What's the spelling?
Calf.
Spelling. C-A-L-F.
C-A-L-F.
C-A-L-F. Okay.
Yeah.
Now, calf is a cow, right? So now the way you want to design is that your calf is a cow. So now calf is a cow. Now whatever the milk functions, what you are saying is all the cows should be able to milk. Now, so even calf can milk. So you will find the milk function in calf also, because you are saying that your calf extends cow, right? That's all you need to say. So cow got all the attributes and the behavior from animal. Now calf gets everything from animal and everything from cow also. Calf gets, I'll repeat here, calf gets everything from animal, meaning animal is a grandparent of calf, right? So cow inherited these properties and this behavior from animal. So your calf also will inherit them, and in addition to that, calf will inherit the behavior and state information that is specific to cow also. So hierarchical inheritance is possible. So if your A is here and your B extends A and your C extends B, D extends C, E extends E, then E will inherit all the properties and all the behavior all the way coming from its super dad.
But only one direction, right?
Only
Inheritance.
one direction. You got it.
Okay.
But nobody can say that now cow extends or calf extends cow and calf also extends goat. You cannot say that. So multiple inheritance is not possible, meaning one class cannot extend calf extends cow, comma, goat. You can't say this. This is not possible in Java. This is called multiple inheritance. And this is one of the most popular interview questions also. Is multiple inheritance possible in Java? we say that multiple inheritance is not possible through inheritance concept, but I'll tell you later. We'll talk about something called polymorphism or interfaces. Okay, and it is possible through interfaces, but not with the classes. You cannot extend multiple classes, and you need to understand this right now in your brain. You need to put it in your brain right now. The reason is it's one of the most popular interview questions. Also, I'll talk more concepts later that rely on this particular concept, but it is possible here. B can extend A. Hierarchical inheritance is possible. You can go to any level. Leveled inheritance is possible. B extends A, C extends B, D extends C. Yeah, let's say if there is a method called eat, you don't need to define here. You don't need to define. E automatically gets eat method. Let's say there is a method called walk here. And then you automatically get it from this walk method. It inherited from C, and it inherited all the it will inherit the methods from D. It will inherit methods from B. It will inherit methods from A. So this multi-level inheritance is possible, but multiple inheritance is not possible through the classes. Did I answer your question, Madhavi? Did everybody understand that? Did you understand that, Madhavi?
Yes.
Wonderful. Any other questions?
Thank you.
No problem, no problem. Any other questions? So in
But
fact,
the constructors,
sorry.
the constructors will keep changing, right? I mean, let's say you from animal to dog, you added you overloaded the constructor, and then
Right.
the next generation will get the previous generation's constructor. Okay.
Yes. Yes.
Got it. Okay.
And just because of this concept, just because Java does not allow multiple inheritance, it is not called pure object-oriented programming language. That is why the real purists call it Java is not pure 100% object-oriented programming language actually. Just because of the, there are more other our previous programming languages like C++ and Smalltalk. These are pure object-oriented programming languages. They allow multiple inheritance. Java does not allow for a very good reason, which we can talk about it later. But it allows it through interfaces, not through classes. Okay. That's about. For that matter, as a matter of fact, your JDK, your Java Development Kit provides a lot of classes, right? It provides about, I don't know how many, 6,000 classes or something like that. So it provides a lot of classes for you to make your life easy. Let's say string is a class, right? String is everything except your primitives are objects, right? Everything in Java is an object except those primitives, those few primitives. Everything is an object. As a matter of fact, every single object in Java, they all extend from either directly or indirectly, they extend from one particular class called object. There is a class called object. This is in a package called java.lang. Java.lang. There is a package that JDK is providing called java.lang for developers to use these objects. Right? It has provided a lot of classes actually, and one of the classes object. This is in java.lang package. Every single object in Java extends from java.lang.object. So java.lang.object has certain methods we'll talk about these methods later, but it has certain methods like a equals. You wanted to find out if two objects are equal or not. That is provided in java.lang object. And there are methods like a hash code, which I'm not going to talk about right now. But there are certain methods like this. What it means is every single object that you define will have these methods. In fact, every single class that you write also extend from java.lang object that you do not need to write. So what I'm saying here is that your animal class here, your animal, public class animal, you did not put any extends, right? But what compiler does, you don't have to put it. What compiler does behind the scenes is extends object. Like this.
Yeah. I think Venkat, if you just create a class, you can show it to everybody, like where it is listed as a super class as java.lang.object. When we create, if you just create a new class,
okay,
in the interface, just create a new class. I just want.
Okay. I'll tell you. Can you let me finish my thought? Just I got what you're saying. I got what you're saying.
Sure.
I don't need a separate class actually here. I'll tell you. So here, but thank you though, Jyoti. Thank you for pitching in. So here, you do not have to say this one, extends object. You don't need to. But your compiler does it. But behind the scenes, what exactly is happening is public class animal, it extends object. You don't need to write it, but your compiler provides it. An object has these methods. Now, what she's saying is, this is what she's saying. Dog dot, see this one? There is a method called equals. You may be wondering, how come I have this equals method? And it has a method called get class. It has a method called notify. It has a method called hash code. It has a method called notify all. How come this dog class does not have any of them? Okay, dog extends from animal. Maybe animal also at least should have it, but even animal doesn't have it. Because animal extends from java.lang.object, and these methods exist in java.lang.object. All of these methods that you see it, wait, toString, notify all, notify, hash code, all of these methods extend in java.lang.object. And your every single class, either directly or indirectly, extends java.lang.object. What I mean by that is, your dog extends animal, but your animal extends java.lang.object. That is why you are seeing those methods here. Did you get it? Yeah. Now, Jyoti, you want to add something to it? That's what you wanted me to show, or something else?
Yeah. That is what I wanted to show. And also, when you just create a new class, it is listed there in the template where we enter the name of the class. There is a super class underneath that. It is mentioned as java.language.object.
Yep.
And the other thing is there is a finalize method also, correct, for this Java.
We'll talk.
Is it specifically for the garbage collection? Just this one question. Just you can tell me.
Yes. Okay. Yep. I'll not talk about any of that, but yes, it is.
No. Yeah. I just have a doubt. So.
Yep. You got it. Make sense?
Yes.
So in your case, my point here is that your dog class extends animal, right? And your animal is not extending anything, so it will automatically put, your compiler puts object. So your dog extends object, your animal extends object, every single object for that matter, every single class that you create in Java extends java.lang.object. And you may be wondering, one small point I need to mention here is that See here, animal extends object, right? This is what it does behind the scenes. You may be wondering, hey, you said that I'm in this package, right? Com Java Venkat Training Java Core Inheritance. I'm in this package, but object is in a java.lang package. And if I use a class from a different package, I need to do here, I need to import java.lang.object, right? This is what I need to do it. But how come I don't have to do this one here? Even though I'm not doing it, compiler is fine. Compiler is not complaining about it. Well, java.lang, it's a language specific classes, right? It is so important. All the classes in java.lang package are so important that it has given you a flexibility that you do not have to import all the classes from java.lang package. In fact, your java.lang.string, for that matter, your string class is inside java.lang package. Your object class is inside java.lang package. Your integer class is inside the java.lang package. Your double class is inside the java.lang package. I'm not talking about the primitives, but I'm talking about the object double. Integer.parseInt, double.parseDouble, remember? All of these classes are inside java.lang, and Java said that, hey, if you're using any of the classes from java.lang package, you don't have to import it. I'm freeing you up from there. But any other package, you need to provide an import statement. That's it. I don't have anything else. We'll talk about more in the next class. I want to talk about method overriding, and then code to interface or code to super type, and then probably polymorphism, interface, abstraction. Before that, before that we'll talk about abstraction. What is the abstract keyword? And are you all following? Did you all follow today's class? Is it too much? Wonderful. Thank you. Thanks, Venkat Krishna. Yep, very good. I'm very happy you're all getting it. Thanks a lot, everybody, and have a good night.